Now in part B, what we've got to do is find what m is, the mass m of Q. And to do that, what I'm going to need to do is eventually consider Q by resolving downwards in the direction of motion. But that involves knowing what t is. So we have to turn to P now in order to get t. We need to consider resolving up the plane in the direction of motion of P. So that's basically where we start. We're still considering P, so let's resolve up the plane. Always resolve in the direction of motion. So if we do that, we've got T for the tension. All of T acts up the plane. Then we've got the friction. All of the friction acts down the plane. So that's going to be minus because it's in the opposite sense to what I'm taking as plus. So it's going to be minus a half times R. And R we found out in the previous part was this unrounded value 2.352. So let's just pop that in there, 2.352. So that's our mu R, the friction. As for R, well, R is perpendicular to the direction of the plane, up the plane, so that has no effect. It's not in our equation. But the weight, that's inclined to this direction, up the plane, parallel to the plane. So we need the component of the weight down the plane. And because that doesn't contain the angle alpha in this right angle, then it's going to be 0.3 g sine alpha. Remember, when you exclude an angle in your 90 degrees, it becomes the sine of that angle. So it will be minus, because it acts down the plane in the opposite sense to this, and it will be minus 0.3 g sine alpha. So that's our resultant force, and that resultant force, because the particle's not in equilibrium, will equal mass times acceleration. And the mass is 0.3 kilograms, and the acceleration is 1.4. So that's 0.3 times 1.4. So all we need to do now is just rearrange this. So if we were to add these two terms to both sides, then what we would have is therefore T would equal a half times the 2.352 and then plus 0.3 g times sine alpha. The sine alpha is opposite over hypotenuse, so that's going to be 3/5. So 0.3 g times 3/5, and then we've got plus 0.3 multiplied by 1.4. So if you work this out on your calculator, take g say to be 9.8, you'll find that therefore T turns out to be exactly 3.36 newtons. So now that we've got the tension T, we can pass it on through to the particle Q. So we can say consider Q. And when we consider Q, we want to resolve in the direction of motion, and that direction is downwards. It's moving downwards. So if we resolve downwards, we've got the weight mg, so therefore we have mg minus the tension, because that acts upwards, and we've seen that that is 3.36, so we can put that in, equals, this is the resultant force, equals the mass times the acceleration. So the mass is m, and we've got the acceleration as 1.4, so we can type that in there. Now if we take g then as 9.8 and take this term 1.4m away from 9.8m, what we end up with is 8.4m. And if we add 3.36 to both sides, we've got 3.36 there then. And divide both sides now by 8.4, and you get m equals 3.36 divided by 8.4, and that turns out to be exactly 0.4. Okay, so hopefully that shows you then how to get m.